The next parent graph is going to be the hyperbola parent graph, which in general, the parent graph equation is where you have y equals 1 over x. Interesting part about this equation is that you are now dividing by your variable or dividing by the input, which makes some very interesting things happen, as you can see with our graph. And part of that is where these asymptotes come from. And so as you're talking about these examples, you have this coordinate point, which is h comma k, which you can then shift back and forth, up and down like anything else. So you can see that I can shift it left and right, I can shift it up and down, and what happens is that center is what we consider the locator point. It's where those asymptotes, the horizontal and vertical one, intersect. Right, and so you can see that now in this scenario, you have an asymptote, and that means that this red line, the curve, gets really, really close to it but doesn't touch it, and this does the same thing horizontally, left and right. And so that creates some interesting things for the domain and range. So let's get to the details. The locator point, as I said, is called the center, and of course it's going to be at HK just like all the others. What does that mean graphically? It is the intersection. It's going to be the intersection of all or both of your asymptotes. So it's the intersection of the asymptotes. Now the graphing form is going to be y equals a divided by x minus h, and then plus k afterwards. Just like all of our others, the h is grouped with the x, or near the x where you're subtracting it. The a is multiplied by, or in this case you're dividing by that x minus h, right? The a could be sitting out front as well. You'll see some examples like that, and then you have a plus k at the end. Now the domain is important because of the fact that you do have this vertical asymptote right here. That vertical asymptote tells me that my domain is going to be that x cannot equal h. It can't equal h. I can equal everything else except it can't be at this vertical asymptote. And the range is very similar, is going to be that y cannot equal k. Right, because if you look at this graph, it never seems to actually touch this horizontal asymptote. So wherever this asymptote is, or these graphs are, right, those are going to be important parts of your domain and your range. Now, both of those examples are written what we call simplified form. We've asked you to write things in interval notation, so we're going to write out the interval notation for these examples, and we're going to keep it simple. We would say that you're going from negative infinity, which is less than or equal to 0, not less than or equal to, just less than, because you can't equal 0, and then you're going from 0 again to infinity. Right, so I wrote this interval notation to be in terms of this original parent graph, not in terms of h. But if you were to shift this graph left, this 0 here would just be your h value. And same goes for the range. You're going to go down from negative infinity. Now we're talking at the bottom, up until 0 again, and then again from 0 to infinity. So what that's saying is going all the way down negative infinity up to 0. You can't equal 0 because the graph never touches it, and then it jumps over it and goes all the way up again. Right? So these examples in interval notation are for your parent graph. If you shifted it left, right, up, down, these zeros would turn into the k value. These zeros would turn into the h value. Now this graph does actually have symmetry to it. The symmetry is kind of a diagonal line actually, and so when you were to write those equations, you'd say that that is y equals k, and also y equals x, and y equals negative x. Those would be your two lines of symmetry. Again, those are in relation to just your general parent graph. If you were to shift this graph up, or down, or left, or right, what you would end up with is that you would have different lines of symmetry that would go through there. So you'd have to write what that equation is as a line instead. We're going to keep it simple for you, just so you know that there is symmetry, and keep it in terms of your parent graph. Finally, your asymptotes, as we've talked about, so much already. Those asymptotes are important aspects of this graph. They're what define it as a hyperbola, and so those asymptotes are going to be both your horizontal, which is at y equals k, and your asymptote vertically is at x equals h. Right? So notice that the asymptote there. The asymptote is what determines whether we have a domain and range. Finally, to finish, you have the syntax for how you type this. That'd be y equals a. You're going to do divided by, but then you need parentheses x minus h, and then plus k. That does tend to confuse students because what they notice here is that we don't have any parentheses around it, but over here you do need the parentheses because you're writing it in a horizontal code. And that's it for your hyperbola.